Hello, welcome to SPMM Revision on Demand. In this podcast, I will discuss the concepts of reliability and validity. A research team comes up with a new scale to measure depression. The scale is called I-mood. They are strongly advocating for using the scale as they claim this will improve your diagnostic confidence and benefit your patients. How can you be sure that the scale is going to be of use? You can test the psychometric properties of the scale, especially precision and accuracy. Precision is more commonly known as reliability. A precise measurement has nearly the same value every time it is measured. Precision is also referred to as consistency, reproducibility, and repeatability. Look at these dartboards. Several attempts to hit the target are shown here. Highly precise set of atoms are shown in the first and the last images. The values obtained in these two images are very close to each other. These are very precise, very reliable atoms. Accuracy is more commonly known as validity. It is the degree to which the results of a measurement correspond to the truth. It is also referred to as conformity or applicability. Look at the dartboards again. Here, highly accurate set of atoms are shown in the second and third images. The values obtained here are rather close to the bull's eye, the target that was originally aimed for. Reliability is a function of random error, the unpredictable inconsistencies that can occur when using a scale. A scale can be devised to reduce but not completely eliminate the occurrence of such inconsistencies. On the other hand, validity is a function of systematic error, and it is affected by bias in the process of measurement. Both validity and reliability can be classified to several types. We will see these in detail in the next few minutes. Let us consider undertaking repeated measurements with the I-mood scale in a set of 50 depressed subjects. I am plotting the frequency of each of the scores obtained using I-mood scale along the y-axis. Let us assume that we know the true severity of depression using another scale, the gold standard Hamilton Depression Scale, for example. The corresponding value of true severity in the sample is shown here. When we now plot the observations from I-mood scale, the further away the I-mood scores are from true value, less accurate they become, that is, reduced validity. On the other hand, the further dispersed from each other the observations are, the less precise they become, that is, reduced reliability. This blue mountain refers to I-mood scores that are very close to the truth, and they are also reasonably close to each other as well. We can say that these measurements are reliable and valid. On the other hand, the green mountain here refers to I-mood scores that are still close to the true value but are widely dispersed from each other. We can say this is unreliable but still valid. This yellow mountain refers to I-mood scores that are far away from the truth but reasonably close to each other. We can say this is invalid but reliable. This red mountain shows I-mood scores that are neither close to each other nor close to the true value. We can say that these set of observations represent unreliable and invalid measurements. The same can be shown using the dartboards as well. First image is precise but not accurate. Second image is not precise but accurate. Third image is neither precise nor accurate. Fourth image is both precise and accurate. It's important to note that both these measures, precision and accuracy, are crucial for a scale to perform well in the real world. Let us now consider the various types of validity. We can examine validity in a superficial manner or in a deeper fashion using statistical approaches. Superficial methods include face and content validity. Deeper examination requires a criterion for comparison. This can be further divided to concurrent, predictive, or incremental validity. The term construct validity refers to the degree to which a test measures the actual construct that it claims to be measuring. For example, does the checklist of a scale capture the issue that is being measured? Of late, the term validity is commonly used as a substitute to mean construct validity. Let us now see face and content validity in some detail. When you look at a scale, you can easily appreciate whether it is a depression scale or a psychosis scale. On the face of it, does the scale appear to relate to what it wants to measure? This is a subjective assessment by people who take it and those who administer it. No expertise is required to assess face validity. Content validity refers to whether the items of a scale represent the construct proposed to be measured. This requires an examination of the items individually and the content by experts in the field of inquiry. Look at the scale shown here. Does it seem to measure depression? It should, because this is Hamilton Depression Scale. You have just assessed its face validity. Comparing the performance of your scale with a specific criteria rather than just definition of the construct is called criterion validity. If a scale is applied concurrently or simultaneously with another scale that is used as an external criteria, this is called concurrent validity. To establish this, we can make comparisons with a gold standard as well. This helps in computing sensitivity, specificity, etc. using 2 by 2 tables. This issue is dealt with in a different vodcast. Two types of concurrent validity are convergent and divergent validity. A new scale should agree with a similar scale measuring the same construct. For example, Hamilton Depression Scale and Beck's Depression Inventory should converge as they both measure depression. A new scale should also disagree with dissimilar scales. For example, Hamilton Depression Scale and Young's Mania Rating Scale should diverge as they measure an opposite spectrum of a different phenomena. A valid scale should have the ability to predict a theoretically related future event. Example, high levels of depression measured using Hamilton depression scores should be able to predict future risk of self-harm or response to antidepressants, etc. This is called predictive validity. For a scale to be useful, it is not just enough to show that it is as good as another scale. It is important that the new scale offers an additional value over and beyond the existing scales. Example, does Hamilton depression provide any more value in assessing the severity of depression in addition to what is gained by a clinician's impression? The answer for this question is offered by the measurement of incremental validity. Reliability is also of several types. In the next few slides, we'll consider these types in detail. If several independent raters are applying the same scale to the same group of patients, there must be a good degree of correlation among these ratings. This is termed inter-rater reliability. When measuring inter-rater reliability, it's important that there should not be much time difference among the ratings, or else the measured phenomena may vary intrinsically reducing the inter-rater reliability. If a single rater is applying the same scale to the same group of patients more than once, there must be good degree of correlation between the two ratings. This is termed as test-retest reliability. When measuring test-retest reliability, it's important that there should not be much time difference among the ratings, or else the measured phenomena may vary intrinsically, reducing the test-retest reliability. Suppose the items of a scale are rearranged to produce two versions of the same scale, form A and form B. Each version is made up of the same number of original items but are reshuffled. Then, if the scale is applied to a group of patients by a rater, both parts of the scale, both forms of the scale applied to a group of patients by a rater, then there should be a good agreement between the two ratings. This is called a parallel form reliability. Two parallel forms are produced from the same number of original set of items with no modifications. Suppose the scale is split into two halves, part A and part B. Each part is made up of half the number of original items. Then, if the scale is applied to a group of patients by a rater, there should be good agreement between the two ratings. This is called split half reliability. Two split halves produced from the original set of items with no modifications should agree with each other. In any reliable scale, the individual items should all measure the same thing. So they should be correlated with one another. This is called inter-item correlation. Similarly, the individual item scores should also correlate well with the total score obtained from the scale. These relationships are captured by Cronbach's alpha or internal consistency. The alpha coefficient varies between negative infinity to plus 1 theoretically. Values close to plus 1 suggest high degree of internal consistency. So far, we've been looking at the concept of validity and reliability in terms of psychometrics when a rating scale is being evaluated. The term validity is also applied to clinical trials in somewhat different context. Assume a clinical trial where a sample is obtained from a population and differences in the effect of an intervention is studied. The degree of confidence with which we can attribute the observed group difference to the intervention is called internal validity. In other words, the internal validity is the extent to which the study allows us to attribute observed effects to the manipulation of the independent variable. In the context of a clinical trial, internal validity refers to the degree to which a study is free from bias. In contrast to internal validity, external validity refers to whether the group difference in a sample can be generalized to the population. In other words, the extent to which we can generalize the study findings to other people or settings is referred to as external validity. This is the degree of confidence with which we can say that the sample represents the population from which it comes. The more pragmatic a trial is, the more generalizable the results will be. Now it's time to ask yourself a few questions. Thank you for choosing SPMM course for your revision.